Okay, so in lesson 9.5, we're going to learn the fifth and final method for solving quadratics, which is the quadratic formula. Just a quick recap, you've learned how to solve by graphing, by factoring, by square root, by completing the square, and today you learned the quadratic formula, okay? And to bring it all together, not only are we learning how to use the quadratic formula to solve quadratics, but now you pretty much have all the tools in your tool belt. So another kind of aspect of today's lesson will be to start to get to select and decide when is each method beneficial, right? When you're given a quadratic, be able to see it and say, hey, I really think this particular quadratic lends itself really well to completing the square or to square root or to factoring, okay? So it'll be a combination of solve by quadratic formula and learn and practice that, and then also start to pick your own method and make decisions about which method you either really like or you think is good for that quadratic, okay? And as we summarize all of that, here's the bottom line. Completing the square and quadratic formula are the two that truly, truly will solve anything and everything, okay? No matter how clean and pretty or difficult and, ugly that answer might be, completing the square and quadratic formula will both reach that solution. If it has real solutions, those two will find it, okay? Graphing will also do that, only with the aid of a graphing calculator. So it's okay if they're whole numbers, but the moment that they're decimals, graphing is really only going to be a tool for every quadratic if you have the technology in your hand to find those exact answers, okay? And then there's the square root method and factoring, which are limited to specific types of quadratics, right? Factoring only works if it is factorable. Square root method only works if b is 0 or the trinomial is a perfect square, okay? So those have limitations on them. So you'll start to kind of be able to negotiate and realize, okay, this one works for this, or it doesn't, or I really like this method, that sort of thing. All right, but coming back to the quadratic formula, this is what the quadratic formula looks like right here. I know it can look a little intimidating, but it's really not too bad. And I promise you, you will memorize it sooner than you ever realize you would, because you're going to just use it, know it. I'm going to teach you a sound that is just catchy and sticks in your brain, and you'll be singing it and knowing it before you realize it, okay? And also just realize it's a formula, meaning it's just a matter, there's really nothing hugely complex about it. It's just about inserting numbers where they go, and then just being careful with your computation. Okay, so in that sense, it's technically a little simpler than some of the other methods because there's not like different steps and different, I guess, procedures that you have to take. You just are literally just like a formula. You're inserting the values in, and then just make sure you don't goof up the computation aspect of it. Okay, the quadratic formula, just so you know where it comes from. I wish I had the time to show this to you. Maybe a little later we will. I'm not going to show it today. But the quadratic formula, just understand, is completing the square when you do it to just a generic ax squared plus bx plus c. So if I took this guy right here, ax squared plus bx plus c, and I completed the square like we have in the last couple of days, okay? Move the c to the other side. I would get minus c. Divide everything by a. A would be in the denominator, right? Then complete the square with b over 2 to the second power, okay, on both sides. And then, if we went through those steps that we've done the last couple of days of completing the square, but we did it with just generic a, b, and c values, this is where you land. This is where this comes from. It's basically just the completing the square done for you ahead of time. So that all you have to do is plug in the values. Yeah, remember, because sometimes we would manipulate something so that we would just have to enter it into that, like with the radius one and the circles. Yeah, remember that? Yeah, it's like that, right? So it's just a completed the square already done for you where you can just plug them in. That's the big idea. All right, so are y'all ready for the song? Okay, pardon my singing, but the whole point is for that to just have something that you can remember. When you put things to music, you're more likely to remember them. So the one that I do, there's different ones out there. The one I like to do is, because I feel like it's very catchy and it kind of gets stuck in your head, is to the melody of that think it's Pop Goes the Weasel, like the little Jack in the Box thing. So do y'all remember the melody for that? Okay, so I'll sing it once, and then y'all have to sing it with me. Okay, so y'all ready? So this is how it would go. Okay, you would go. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And the crowd went wild. All right, so y'all ready to do it with me? Okay, everybody does it together. We'll have to do it again, so do it. Okay, ready? 5, 6, 7, 8. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Yay. Yeah. So, what's that? It's catchy. And then you'll sit there and be like, X equals negative b. Oh, yeah, that's right. And it was like, okay, that's it. It's done. The music, it's amazing how music helps us remember stuff. Okay? Okay. So let's put it into action and let's see what this looks like, okay? So because it's not on this slide, I'm going to write it one more time. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So y'all are already pros. I love it.
Easy.
Easy peasy, that's right. Okay. So we'll have it right there for easy reference, but the song really does help. Just like, oh yeah, what is it over? Oh, over 2a. That's right. You'll catch it like that. I promise. Okay. So the directions here say solve the quadratic equation using quadratic formula. Write your solutions both in simplified radical and a decimal if necessary. So if they don't come out to whole numbers, we'll make sure we leave our answer in both ways. Okay. So here are the prerequisites for us to use the quadratic formula. The main thing for quadratic formula is that we do need to set it equal to 0. We haven't done that in a while, but in this method, we set it equal to 0. There's three methods, where we have to set it equal to 0. Graphing, factoring, and quadratic formula. In those three methods, we set it equal to 0 to do the method. For completing the square, we don't. We move things over, we add a c in there, all that stuff, and same thing with square roots. We isolate the x, so our goal is different. But for graphing, factoring, and quadratic formula, we set it equal to 0. That's really important. So make sure it's set equal to 0. This side is in standard form. And probably the most important thing is identifying what is my a value. So here, what's a? 1, right? What is the b value? Negative 10. And what is the c value? Exactly. Notice I did not include any of the x's in there. No variables. We are literally just entering numbers, just values. Okay? Is that okay with everybody so far? Okay. So now that you've identified the, hang on, sorry. I'm so upset. Okay. Now that we've identified those, now we can proceed to actually plug them in to the formula itself. There it is. Okay. So again, part of it is just being careful how you plug it in and computing things carefully. So I'm going to tell you where the goof ups tend to happen. And the first one is right at the beginning. One of the big goof ups that kids do sometimes is they forget about the negative in the formula when they put in a negative b value. There's two different negatives there, guys. There's a negative that was part of our x equals negative b, right? And then I'm inserting a negative 10. So when I start to simplify that, what's going to happen there? It's going to become a positive, right? So it's really the opposite of whatever b is. So we've got negative, and then my b is a negative 10. Those are two separate negatives. Don't blend them into one, okay? So plus or minus the square root. Here comes the other and really big one. Y'all listening? Especially because I know most of y'all are going to reach for the calculator and are going to probably use, and that's okay. I'll show y'all how to put this in the calculator. That's not a wrong thing to do. The moment that you do this right here, and then you write the rest of it, this whole answer just went sideways on you. Okay? Okay? This is going to be 100% wrong every time. What mistake did I make right there? No parentheses, right? You want to square b. B is a negative 10. Especially on the calculator, if you don't put a parentheses around that, you just miss that entire problem. Even if you did everything else correctly. You could have done everything else like poster perfect. If you didn't put a grouping symbol around that, you just got that whole thing wrong. Okay? Because the calculator is not a smart thing at all. And it does not know that you mean negative 10 to the second power. It thinks you want the negative of 10 squared. It does not know that you want to include the 10 in your base that you're raising to the power of 2. The only way you can tell that to your calculator is hugging that with the parentheses. I've been trying to warn y'all since August that this was coming. This is where it really hurts because you do everything else so correctly. And then just that absence of that grouping symbol completely ruins the answer. Okay, so make sure you hug that with parentheses right in there. So b squared minus 4 times a times c. Okay? And all of that is over 2a. Okay? And as long as you insert everything, then the rest of it is just careful computation, order of operations kind of stuff, right? So now we can take care of some of the simplifying here. A double negative here becomes a positive 10. Negative 10 squared, negative 10 times negative 10 is 100. I almost feel like with these, it's better to do it kind of in your mind because just the calculator is great, but if you don't tell it exactly the right way, then you could make some mistakes there. So that's 100. What about over here? Minus 4 times 1 times a negative 16. So what is 4? Oh, sorry. Why is that a negative? Sorry. That was my mistake. I apologize. I don't know where I got that. Thank you for catching that. Okay, it's a positive. I don't know. I saw this, and for some reason I looked at that as a negative. Okay, so minus 4 times 1 times 16. Well, what's 4 times 1 is 4. What's 4 times 16? 64. Well, we're subtracting it, so yeah, it's negative. And then 2 times 1 is 2. So here we are now. Okay. Still have to work inside the grouping symbol before I do anything else, right? So what's 100 minus 64? 36, yeah. So then this simplifies to 10 plus or minus the square root of 36 over 2. Is the square root of 36 a perfect square? Yes, it is. So what's the square root of 36? Yeah, so this really simplified out nicely to just 10 plus or minus 6 over 2. And at this point, this is as far as I can go with the double sign. So basically what we've done is this whole time, we've had that plus minus in there, and we've kind of have been working two problems together at the same time for as long as possible. But here, I can't really solve this any further without actually branching out and kind of separating out my two answers. One of my answers is going to be when I do 10 plus the 6, and then I divide that by 2. So 10 plus 6, 16, and 16 divided by 2 is 8. The other answer is going to be when I do 10 minus 6 over 2. What's 10 minus 6? 4, and then 4 over 2 is just 2. So guys, the solutions to this were x equals 8 and x equals 2. There they are. Okay? It's not that bad. Now, if I had choices, I probably would have looked at that at the beginning and been like, oh, I think that factors, 2 factors of 16 that add up to 10, 8 and 2, right? But first of all, I didn't have a choice here. I had to do quadratic formula. But also, you can just see that it works for everything, okay? When you have the choice, great. Then look at it and decide maybe factoring is better. But if not, then just make sure you do the methods they ask you. Yes, that's on the test, yeah. Mm-hmm. Absolutely. Okay, you definitely need to know the formula. Yeah. Divide what by 2? Well, if you wanted to distribute the division and make it a 5 and a 3, you could. But you'd have to make sure you divide both. Yeah. Okay. All right, let's try. Actually, let's jump. Number 2 is pretty similar to that. Just, for sake of time, let's do number 3. Okay, so on number 3, if we take a look at that one, is it already equal to 0? Okay, all right, it's equal to 0. And let's identify what A, B, and C are. What's A here? 3. What's B? -1. And what is C? -2. All right, now let's plug those in. So we've got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. All right. I don't really have to sing it to myself, but I figured it would help y'all. I'm trying to make this song get stuck in your head. Okay. So now we simplify things out, make sure everything got entered correctly. All your inputs are in parentheses. That's going to be a big help. And it's a -2 and a -b, but the 3 is positive. All right, that looks good. All right, let's start cleaning things up. The first term, double negative on the 1 becomes a +1. And then -1 squared is just 1. And then a -4 times 3 is a -12. And -12 times a -2 is a +24. I'll need that much here. Okay. All of that over 2 times 3, which is 6. Okay. And then 1 plus 24 is what? 25. Hard math here, right? And then over 6. And then the question is 25 a perfect square? Yeah, so actually we can take this all the way home then. The square root of 25 is 5. And I can then make that a whole number. We don't have to deal with decimals and all that. And then we branch this out. One answer is 1 plus 5 over 6, which is just 6 over 6, or 1. That's one solution. The other solution is 1 minus 5 over 6, which is just -4 over 6, or in other words, a -2/3. Those are our two solutions. X equals 1 and x equals a -2/3. And there are our two solutions. The more you do it, the faster it starts to get and the more comfortable. This is probably one of your favorites, I promise, because it will solve everything. Okay? All right, let's take a look at number 3. Let's try number 4. Is it equal to 0? Then be really careful. Do not start identifying A, B's, and C's before setting it equal to 0. So let's move the 13. Do this one with me. Okay, and rewrite it in standard form, set equal to 0. So we got x squared plus 6x plus 13 equals 0. That makes A equal to what, guys, here? 1. B is 6. And C is 13. Okay? So then let's insert that into the formula. X equals -b plus or minus the square root of b squared minus 4ac. All of that over 2k. Just like that. Okay? See if that's what you got when you entered all the values for A, B, and C. Are we okay with that? All right, so if we do that then, we're going to do x equals, this negative of 6 is going to be a -6 here, plus or minus, what's 6 squared? We get 36 there. And then minus, or a -4 times 1 is still a -4. And then what's 4 times 13? It is 52. Very good. Okay. All of that over 2 times 1, which is just 2. Now, what is 36 minus 52? -16. So now we have x equals, x equals -6 plus or minus the square root of -16 over 2. And therefore, what do you notice? What do you think? No real solutions. This is a big issue here. We cannot take the square root of a negative Therefore, this has no real solutions. You can stop there as soon as you realize that that radicand inside the radical is a negative. Then you can say, you know, I'm stopping here. This has no real solutions. You cannot take the square root of a negative number. Okay, how do y'all feel about those? Okay, good. Let's try one more. Try number 5 on your own. I'll give you a minute to work that one out. And then if y'all feel good about it, we'll go to the word problems. Okay. I'll give you guys a little bit of a head start. And I'll start working it out up here for y'all to check. Okay, so I get A is -3, B is 5, and C is 6. When I put that into the quadratic formula, it's going to be negative B plus or minus the square root of B squared minus 4 times A times C, all of that over 2A. Okay? And then it's just a matter of order of operations and careful, computation. We get -5 plus or minus, and here I get 25, and then negative times a negative is a positive. That's what, 12 times 6, so I get 72 there. All of that over a -6. And then 25 plus 72, very good, gives me a -5 plus or minus the square root of 97 over a -6. Okay, is 97 a perfect square? Does it have any perfect square factors? We could check, but I'm pretty confident it does not. And we'll check in a moment, but then if not, then we're good. Now those double negatives you can cancel. You can kind of change all your signs here, which doesn't really change there. So really we could say here x is equal to 5 plus or minus the square root of 97 over 6. Now it did also want the decimal version. So this is a simplified radical form right here. It also wants the decimal approximations here. And that's a good time for us to practice how we would put this into the calculator. So let's talk about that for just a moment for the calculator. Here's the deal. If you're going to use a calculator on these, first of all, that'll be fine if your answer is going to be a decimal. If it does want simplified radical, calculator's not going to be very helpful for you to get here. But it can be helpful to get to the decimal part. However, I know the question is going to be, well, what kind of work do we show if I'm using the calculator? Well, the answer is this right here. Okay, you show me what you entered in the calculator. You show me how you used the quadratic formula. Okay, I would need to see this on your sheet of paper so that I know, oh, that's what they entered in the calculator to get the solutions they got. Okay, and it also shows me the evidence of the method that you used. And then I can come in here and plug it in. Okay, you want to pull up a nice long division bar because that's definitely existing in the calculator or the bar? The division bar is alpha y equals. And then just hit enter on the first choice and it gives you the division bar. Okay. Now for this one, it's 5, right? Plus, you can't do the plus or minus together. You're just going to do one at a time, but I'll show you how to make a shortcut for that. So you got 5 plus the square root. Everybody okay with that? of 5 squared minus 4 times A times the C value. What was our C value? 6, right? Okay. So I'm literally entering everything just like that. So I've got my 5 plus the square root of B squared minus 4 times A times C. All of that over 2A. There it is. The entire formula. I can hit enter. There's my first decimal. Now, check it out. I don't have to recopy that. If you have some of the newer ones, I can just up arrow, select that, hit enter, and then I can just come back in and change that addition to a minus. Just make sure it's a minus, not a negative. Okay? So I come here, and I say right in here, I want a minus instead, and there is my second solution. And we're good to go. Okay, so now that we know how to put that into the calculator, let's go back to the problem and write our decimal answer. So one answer is approximately negative 2.4. Well, actually, we're running to the 10th place, I believe. So it's going to be negative 2.5 and negative 8 tenths. So approximately, all right, negative 2.5 and 8 tenths, right about there. All right, let's take a look at number 6. Number 6, we need to set it equal to 0, so we'll move that to the left. So now we have negative 4x squared plus 8x plus 6 is equal to 0. That helps us identify, well, we have to do that before we identify that A is going to be a negative 4, B is going to be 8, and C will be 6, and then we can put those in the quadratic formula. So negative 8 plus or minus the square root of 8 squared minus 4 times A times C, and then all of that over 2 times A. Okay, and we'll clean that up. This comes to just negative 8 plus or minus the square root of 64. And then here we get a negative 4 times a negative 4 is a 16. And then 16 times 6, I believe, is 96. All of that over negative 8. And then when we add 96 plus 64, that should be 160. So we're here now. And we're at negative 8. Negative 8 plus or minus the square root of 160 over negative 8. All right, now, right in here, 160 is not a perfect square, but it does have 16 that goes into that. So we can write that in simplified radical by separating out that 16 and the 10, oops, that's not 10, times 10, and then factoring that out, that square, or not factoring, but taking the square root of that 16. So when we can take the square root of the 16, we're really going to end up here with negative 8 plus or minus the 4 square root of 10 over negative 8. And then I want to recognize that there's this kind of this GCF among all three of these whole numbers, right? I know that actually negative 4 goes into all of that. That's probably the easiest to do here. So I can divide everything by a negative 4 here and just leave this answer as 2 plus or minus the square root of 10 over 2. So everything is divisible by a negative 4 there. Okay. And that is the simplified radical form solution. And then, of course, you could grab your calculator and estimate those answers out. So one answer is going to be, let's see, we're going to put that as a fraction. So one answer is going to be 2 plus the square root of 10 over 2. And And that's one solution there. And then the other solution is exactly the same thing, but we are going to use subtraction in the operation at the top here. We're going to put a subtraction there, and then that's your other solution. So we're looking at 2.6 and negative 0.6. So approximately 2.6 and negative 0.6 would be the decimal there. Okay, so now that we are comfortable with the quadratic formula and we know all of the 5 methods, the idea is take a look at the different choices and what are their advantages and disadvantages, right? When does it make sense to use one over the other? And start to look at quadratics and hash out, oh, this one's a really good candidate for, factoring or for graphing, that sort of thing. So this is a good example of that. So you have a square pool that has side lengths of x feet. I'm going to draw that. Here's my square pool. All sides are x feet. And then you have a uniform border around that that is 1 foot wide. So that adds a foot on every side here, a foot all the way around, okay? The total area of the pool and the border, so that really means the total area of this larger square that includes both border and pool together, that area is 361. And we want to just find the area of the pool, which is, I need to find x, and then I can use x for that. So if I set this up, since it's a square, let's go ahead and come up with the expression for the dimensions of the outer square. So the pool was x, sorry. And then if I add kind of 1 foot on one side and 1 foot on the other, I'm really adding a total of 2 feet when you consider the fact that we're increasing this by 1 foot on the right and on the left. And it's a square, so the same thing is going to happen in this dimension. We're starting off with x, which is the pool, and then I'm adding 1 foot on top and 1 foot beneath. So really my square that includes border and pool is x plus 2. And because I know the area of a square is just the side length squared, the area for this is just going to be that side length, that x plus 2 side length squared. That is how we generated that 361 square foot area. And once I set it up like this, right, I can look and realize this is a really great candidate for us to use the square root method. This is already written as a perfect square, and all I have to do is take the square root of both sides. So square root method is a great choice of this problem. You could do any choice, but this is a really good choice in particular. It cancels out the quadratic and really just leaves me with a pretty nice, simple one-step equation here, which is equal to technically positive negative 19. That's the perfect square. 361 is a perfect square. However, because this is the dimensions of a side of a pool and its border, really the negative does not make sense here. So I'm really just going to entertain the positive option because I know negative is not reasonable. And then all I have to do is subtract the two. So the pool side is 17 feet. Okay, so the side length is 17 feet, but the question actually wanted to know what is the area of the pool. So now I have to go back and find the area of the pool, which is also square. We're just going to do that side length squared. So when I square that, I believe this is 289, and that's in square feet. And that's the area of the pool. So that takes care of finding that, and it allowed me to use any method, and I really think that square root method would have been really smart for this one. Okay, last one, word problem here. Your friend competes in a high jump competition at a track meet. The function h equals negative 16t squared plus 18t models the height in feet of your friend after t seconds. So how many seconds is your friend at a height of 4 feet? So first of all, if it says how many seconds, then what we're looking for here is a value of t when the height is 4. So I'm just translating this how many seconds means we're looking for a t value, and if the height is 4 feet, that means we're wanting to set h equal to 4. So I'm going to go ahead and take this function we were given, and set it equal to 4. But then pretty much as soon as I do that, I'm going to move that 4. Well, I guess I need to decide my method. I'm thinking here, these are big numbers. There's an a value. I'm just really feeling like this is going to be, maybe quadratic formula would probably be the best here. Just because I don't see things factoring very nicely, that kind of thing. So I'm just going to move the negative 4, set this equal to 0, and then I'll just use the quadratic formula here. So I got negative 16t squared, that 18t, and now I have a negative 4 on the same side. I'm going to identify A, I'm going to identify B, and I'm going to identify C, and I'm going to insert them into the quadratic formula. So the quadratic formula is negative b plus or minus the square root of b squared minus 4 times a times c, and then all of that over 2a. Okay, and I think at this point I'm probably just going to reach for the calculator. And so when I insert that, clear this out, I'm going to pull up my division bar. So my first term, B is an 18. So I'm going to do negative 18 plus the square root of, again, that b value is 18. So b squared minus 4 times a, and then times the c value, and then all of that over 2 times a. So that's the entire quadratic formula there, with that a of negative 16, b of 18, and c of negative 4. So the first time that my friend hits a height of 4 feet, looks like it's about 0.3 seconds. And then I need to find the other solution. I can just select this and change that addition to subtraction to find the other solution, or x-intercept, the other root. So I'll put a minus in there, sorry, and then at about 0.82 seconds. So our answers are at approximately, so my friend hits 4 feet at about, what was that, 3/10 of a second? And again, after about 8 seconds. Okay. And then it says, after how many seconds does your friend land on the ground? Well, when I'm on the ground, my height is 0. So I will take this same equation again and set it equal to 0 this time. In this case, though, I don't know. I'm thinking factoring might be better than quadratic formula. I see a GCF in here. I can pull a negative 2t out, and then that leaves me with 8t minus 9. So I'm doing factoring here, and then I can, take each factor and set it equal to 0. The zero product property says I can take this times this. If those two things equal to 0, then either negative 2t is equal to 0, or 8t minus 9 is equal to 0. And when I solve this, that's still going to be times 0. So yes, we're on the ground at the beginning when time is 0. And then the second time that we're on the ground is when we do about 1 1/8 seconds, it looks like. So when t is about 1 1/8 of a second, they're back on the ground. There you go. So all of the different methods there. And that's a good way to see when they're, best to be used.